let's continue. This was CSMA CD, which hardly nobody is using now because as we are using switches nowadays, so CSMA CD does not require to be enabled in CSMA, I mean in switches, sorry. So now simply, as I've told you, by default, whenever you connect the devices, whenever you configure the devices, or whenever you link the devices to the switch, they are all in the single broadcast domain. So in the single broadcast domain, if you have all the devices like 250, 100 devices connected to one switch, that means it's going to, pressurize the switch, and there will be less redundancy, or you can say less latency. There will be the problems in between the communications sometimes because you will put more pressure on the switch, and it can create problems at that time. So what we do is we have something called as VLAN. So what VLAN is? VLAN, it's local area network, but V stands for virtual LANs. All right, that's virtual LANs. They're basically grouping. Basically, they are logical grouping, or you can say VLANs are logical grouping of devices in the same BROAD broadcast domain. So VLANs are usually configured on switches by placing some interfaces, or you can say ports interfaces into one BROAD broadcast domain, and some interfaces into another broadcast domain. So each VLAN acts as a subgroup of the switch ports in an Ethernet LAN. And VLANs can spread across multiple switches, with each VLAN being treated as its own subnet or broadcast domain. So this means that frames broadcasted into the network will be switched only between the ports within the same VLAN. Now, what is VLAN? This is just a general concept which I've told you. But what VLANs are? I have given you the concept. I have told you what are subnets, right?
Yes.
In subnets, we are basically dividing a network into different parts. In the same way, over here in local area networks, in switch, we have only devices. Now, all the devices are within the same area network. Suppose that this is the network 100.0/24, right? So we'll have 254 IP addresses, and by default, they are under one. By default, they are under one VLAN, which is VLAN 1, and they are in the same broadcast domain. Single broadcast domain, BRA. They are under the same broadcast domain, right? Now, what we can do is, now, if you talk about subnetting in IP addresses, same thing happens over here. We are not now taking about subnetting into consideration. We are just now taking the interfaces of switches into consideration, and we are basically changing their broadcast domain. By default, these 254 IP addresses are in the single broadcast domain. That means they will be able to ping each other. Ping each other. And remember one thing, by default, all the interfaces of a switch are under VLAN first. By default, all the interfaces of a switch are under VLAN first. Remember this thing, right? And they are in the same broadcast domain. Now, if suppose that it's not necessary always we should, use routers. Routers are very expensive than switches. That's why we require VLANs. We basically use switches and create departments based on switching. Not like we use routers every time and create subnets for this and this. So we use local area networks and we use switching to create, VLANs, so that we just differentiate, or we just separate the network, even though the network is same. The same IP address is used, which is 100.0 is the network ID, but we are providing the security. We are not letting the departments to communicate each other by configuring the VLANs. So that's basically we are dividing them into different parts so that they will not be able to communicate. Suppose that we have this network, so from 100.1 to 100.50 we have one broadcast domain, and it's, suppose that now VLAN 10, and this is IT department. We can name it as IT department. All right, and then from 100.51 to 100.100 we have another VLAN. This is another broadcast. So by default these all computers were in the same broadcast domain. I will later on tell you what are the differences. Why should we go for the separate broadcast domains? I will tell you all the advantages of dividing a single broadcast domain into multiple broadcast domains by VLAN. So VLAN 20, name is, you can say, HR department. So this becomes very cheap to create VLANs or configure VLANs and separate the network of HR department or IT department or whatever, even if you have this particular network. So, and so on, etc. The networks, that from 100 now 101 to 50, and you will it will become like about 5 VLANs if you are about to go and just write all the IP addresses with VLANs. So what we do is, so each of the IP is in the same network ID, but they will not be able to communicate when you separate them. That's the main important thing what VLANs are able to do it. If you want them to be communicated, you need to have a router. All right. So what's the basic difference? And a VLAN acts like a physical LAN, but allows hosts to be grouped. Physically, you can say they are in the same local area network, but logically they have been separated. They have been separated and they have been divided. It's just like a subnet have been created for them using the VLANs. So in routers, we create subnets, but in switches, we create VLANs. That's the main important thing. If you understand your the routers, you know about subnetting. We divide the IP address. Here we divide the MAC addresses, but we divide based on interfaces. You understanding?
Yes.
So the reasons why VLANs are used. First thing is VLANs increase the number of broadcast domains, because by default, as I've told you, a switch or switch is having all the interface on the single broadcast domain. When we configure them using the VLAN, so they are going to increase the number of broadcast domains, but they're going to decrease their size while decreasing their size. So by default, if you have 252 IP addresses, that means this was a very huge size. When you divide them, when you increase the number of broadcast domains, you are basically decreasing the size, because now if you can see, there are now only 50 IP addresses in this broadcast, 50 over here, By default, it was 252. So that means we are decreasing the size by increasing the broadcast domains. You understanding?
Yes.
Next thing is VLANs reduce security risks. How? By reducing the number of hosts that receive copies of frames that the switch flood. SWITCH switch flood. SWITCH switch flood. So if a switch is going to flood the frames or copies of frames, so if they are in the same broadcast domain, that means all the particular 252 devices will get the flood requests. But if it's, for example, IT department is there, HR is there, so it will just secure, you know, the floods from the switches, basically, because when a switch will try to broadcast, every particular port interface will be under the different particular, you can say VLAN, so it will just drop the packet at the same time, so it will never allow a switch to, or it will never allow a switch to, you can say, flood any particular packet or frame. You understand?
Yes.
And you can keep hosts that hold sensitive data on the separate VLAN to improve security. So we can, or you can, what is that? We can keep hosts, or you can say devices, that hold sensitive data on a separate VLAN to improve security. So what do you mean by it? If you're a network designer, in a network, if you know that what network is all about, in a network, we used to have our own database servers. We used to have the servers where we used to have our very important confidential information. So we can put those devices, suppose that we have web server. I mean, just a portal, our own web server. We have web server, or we can say we have data server, database server, or any particular confidential information that we do have on a host, we can put them under a separate VLAN, which will help us to improve the security. So IT or HR people those who do not have the information about what this web server is, they will not be able to, you know, communicate with it, and it's going to improve the security. Are you understanding?
Yes.
And also you can create, or we can create, flexible network designs that group users by department instead of physical locations. So simply, as I've told you, we are basically logically, we are grouping, we are creating groups, we are designing a network logically. We are not designing it physically. Like, for example, physically, we are dividing, you know, we have devices, we put all the devices in IT department, that's physically, another devices in the HR. But logically, we can define, suppose that this device, this interface will be gone to IT department, this interface will be going through, you can say HR department or finance. That's logical grouping, logical designing using VLANs. Are you understanding?
Yes.
So network changes are achieved with ease by just configuring a port into the appropriate VLAN. So you have to make the change in the networks tomorrow if you want another computer to be, you know, in the same VLAN. So you just need to configure that port under which VLAN. So it's very simple to configure, and it will also improve the security. So very simple example I'm going to give you about, these were the major differences why, or reasons why do we need VLANs. So I'm going to draw a very simple, you know, example for you here. Suppose that we have a single switch here, and we have devices like two here. We have two devices here. Suppose these are 50 devices, not an issue. So 3 devices here and 3 devices here. I'm talking about big ones. So this is 1 and this is 2. Even they have the IP addresses within the same range. So 192.168. Suppose 10.0 is the network. So 1, 2, 3, 4, 5, 6. So by default, they are in the same VLAN, which is VLAN first. They will be able to communicate each other. But when you configure, like for example, this is IT department. So I will configure a VLAN 20, and I will put them under the IT department. All right. And then there is this VLAN, which is HR department. And now when you configure and implement and allow an interface to, you know, be in the HR VLAN, then if you try to ping this device with this, you will never be able to ping. For that, you need to have a router. Understood? So that's logical grouping. Physically, they are. You can see they are in the same network. What is happening? This is a local area network. They should be able to communicate. But logically, they are differentiated. They have been subnetted. You cannot say the word subnetted. You can say they have been divided into separate VLAN. This is the same thing what happens in routers. Why do not we require, or why do not we create different subnets and connect them to the router? Because then we need to have more routers. So what we do, routers are more, you know, costly. So switches are more cheaper. So we can go with switches and then use more switches in a network, and we can have 1 or 2 routers, the gateway routers, through which we can send the traffic out and receive the traffic inside of a company. So that's the main reason. So I hope you understood the concept.
Yes.
So without VLANs, a broadcast sent from host A, or you can say this is host A and host B, as I've told you, it's going to be received by on the network. Each device will receive the process broadcast frames, increasing the CPU overhead. So it will just also increase the overhead by default when all the computers will be having the same VLAN on each device, reducing the overall security of the network. So now let's go, and I'm going to now tell you the most important thing. Now, when you configure VLANs, there are 2 ports in VLANs, access and trunk. What are these ports? You need to understand them. It's very important to understand them. Yeah, any idea about access port and trunk port?
Access port will allow only one VLAN to go through. Trunk will allow more than one VLAN.
First thing is correct, access port. What's trunk port?
Trunk will allow more than one VLAN.
Yeah, so basically, can we connect a trunk port to the device, to the host?
It's mostly connected to routers or other switches.
That's the main concept. Okay. Yeah, you're true, but we cannot connect a trunk port to the device. Basically, trunk port is helping us to carry the traffic of multiple VLANs, but it's going to carry them from switch to switch. So trunks will be used from switch to switch, not from the switch to device. Are you understanding? I'm going to tell you. If we use, or if we intend to use VLANs in our network, we will need to configure. So whenever you wanted to configure VLANs in your network, you need to configure some ports on a switch. Not some, the ports that you want. So some ports on a switch as access port, and some access ports and other as trunk. So what is access port now? Access port. So a port that can be assigned to a single VLAN. This type of interface is configured on switch ports that are connected that are connected to end devices, that are connected to hosts, you can say, such as workstations, printers, or access points like your Wi-Fi's and all. Okay? So access ports are used when you will allow a VLAN to be configured on, or to allow a VLAN, or you want a particular printer to be inside a particular VLAN, you are going to use access port. You're going to tell the workstation that you will be able to access, or you will be configured to remain in the VLAN, for example, 10, 20, or 30. Over there, we are using access ports. Are you understanding?
Yes.
That's access port. And now if you talk about trunk port of a switch, a port that is connected to another switch called as access port. When you have example of access port is, I'm going to draw a simple topology. So this is a switch, we have a device. So this is called as access port, AP. If you have another particular host, whatever the host is, can be a server. So this is access. And but if you have another switch here, this is trunk port, this is trunk port, this will be trunk. They are basically going to carry now. For example, we have this computer and this computer, okay? We created VLANs, and then, for example, this device and this device are in the same VLAN, and this device and this device are in the other VLAN. So this trunk port, or this trunk interface, this cable will, you know, carry the traffic of both the VLANs. That's why they are called as trunk ports. This is access, this is access. But when you link two switches together to carry the traffic of VLANs, it's called as trunk port. Even if you have one more switch here, so this is called as trunk port, and these are access ports. Are you understanding?
Yes.
So that's what trunk port is, or you can say, and interface port is. So this type of, you understood, Sana, now?
Yeah.
This type of interface can carry traffic of multiple VLANs, thus enabling you to extend VLANs across your entire network. That's it. And now we will go and start configuring the VLANs. Okay. So these are the concepts of switching, and this is what VLAN is. And now you need to, most importantly, remember this thing. What are the two ports? One is access port, another is trunk port. All right. Why should we enable trunk, and why should we enable access? This is the very important thing that you need to remember. So configuring config, oh my gosh. Configuring VLANs. VLANs. So as I've told you, this is the thing you need to remember. By default, all the ports on a switch are in the VLAN first. I will show you that too. And you can verify it. Oh my gosh. We can verify it by typing show VLAN command from the iOS enable mode of switch. So show VLAN command will help you to check or to verify whether all the ports of an interface are under, VLAN first or not. So VLAN, it's VLAN first. I have just deleted. Hello.
Yeah.
Now, we'll go ahead and open Packet Tracer. This is today's first practical. And I hope you have no questions so far. These were the theoretical concepts. You need to understand them, and even you will go through them again. Okay, so I will add one switch, and now we are all about devices. 1, 2, 3, 4, 5, 6. Even if you want, you can add a router. Okay, so 2, 3, 4. This is our first topology of layer 2 switching, or you can say switching. And then configuration, so far I'm going to go with static 192.168.10.1 with the same default gateway is not required, not 10.1, so 10.2. Maybe we require it, 192.168.10.1. Then I'm going to go with the desktop IP configuration 10.3, 10.1. 10.4, 5, 10.6, and 10.1. IP address or configure, when we obey, you can see these are all the ports in the switch, so we do not need to add any ports here in this particular, switch. So modules, all the modules are added. In routers, we need to add, but here already these are the ports which are added. We don't have to care. So all the protocols are up. So switch enable, and you can see right now, show MAC address table. Sorry, show VLAN first of all. I will talk about. So show VLAN. No, it's not clock. Show VLAN. You can see when you type in the command show VLAN, you will see by default show VLAN. So VLAN first is the default name and active. These are all the ports which are inside it. FOSS Ethernet 0/0. Wait a sec. So yeah, you can see starting for FOSS Ethernet 0/0, 0/2, 3, 4, 6. So these are the ports, and there are 2 gigabit Ethernet ports. So they are all by default in the same VLAN, and the VLAN name is first. You understand? And there are other VLANs which are not used by us. 102 FDDI default, token ring, FDDI default, Tornet default, and these are VLANs in it. So these are VLAN 1, 102 FDDI, and we can never give the VLAN number like this 1002, 3, 4 because they are already been assigned to these services. All right. So we have to always give the separate names of VLANs when you configure. So these are all the VLANs, and by default, now if you wanted to, you know, communicate with each other, suppose that I want to go to ping to 192.168. For example, 100.7, sorry, you will be able to ping. So ARP request is sent for the MAC address. Timeout. There is a problem. Do we have the IP address? This 10.7, 10.1. What's the problem here? Oh, 10, 10, 10, not 100. It's 10.7. So you can see replies are coming. So we're able to communicate by default. So by default, they are in the same local area network. So LAN 192.168.10.0/24. They will be able to communicate. But when we configure VLANs, it's going to be a different thing. Now, to configure the VLANs, what you need to do is for the configuration of VLANs. So to configure, there are 2 steps. Only just 2 steps. 2 steps. First, create. What you have to do is we have to create a VLAN using the command VLAN number. First of all, VLAN number. Second, assign a port to the VLAN, like access port, by using 2 interface commands, interface sub commands. So the first command is switch port mode access. That's, we are telling the port that you are having this mode, the switch port mode access command. This is the first one. Then another one is, which is going to specify the interface is an access interface. The second command is switch port access. We're telling the switch that which particular VLAN you have to, you are being assigned to VLAN number. So these are the 3 commands basically we need, but steps are 2. First of all, we're going to create a command using VLAN number. This is the first thing. Second thing is we are using the command switch port mode. We are telling that you are in the access mode. I told you there are 2 modes of each interface on a switch, trunk mode and access mode. And then you have to tell the computer, tell the interface or computer in which VLAN you are. So these are 3 commands. Let's go ahead and now try to configure. But again, I will tell you, remember one thing you can see. These are all the interfaces which are on the VLAN first when I will configure, and they will change, okay? Now let's go ahead. So first thing is in the global configuration mode, here also we have the same configurations, same commands, config terminal. So we will use VLAN and number is, for example, 10, or you can say 15, VLAN 15, and we can even name a VLAN name. Wait, name. Yep, so we can say IT department, and then exit. If you want another VLAN to be created, we will create tool VLAN. So VLAN 20, name HR department, exit. Now we created VLANs. So it's up to you how many VLANs you want to create. All right, so 2 VLANs I have created. One is VLAN number 15 and another is 20. You need to remember this VLAN number 15 and 20 because we will use it while assigning a port on an interface using the VLAN. So 50 is for IT department and 20 is for HR department. Now we have to assign them on interfaces. We have fast Ethernet 0/1, 2, and 3. Up to 3, we will assign them to IT department. 3 devices will be assigned to IT and 3 devices will be assigned to HR. So what we will do is, next thing is we have to access the interface. So we'll go to interface fast Ethernet 0/0. Are you here with me?
Yes.
Yes.
So remember this thing, first I created VLANs, we can create 3, 4, but I require 2 only. There are 6 computers, 3 will be in one VLAN, 3 will be in another VLAN. So interface fast Ethernet 0/0. What happened? Oh, sorry, there is 1, not 0. 0/1. And now you have to use the commands. What? Switch. You have to first of all tell the interface that you are in access mode. Switch port mode access. Now this is access port. Hit enter, and now you have to tell the port that you are being assigned to which VLAN. Now we will again use switch port access VLAN. What's the VLAN? VLAN is 15. So 15. Yeah, 15. I have just used 15. So 15. Khalas. And now exit from this interface. If you check now, go to exit, you will check show VLAN. Check here. There is a VLAN 15 IT and there is one more VLAN 20, which is HR. Active FA fast Ethernet 0/1 is inside the VLAN 15. You understand? There is 20 also, the name of the VLAN is HR, but there is no port inside it. Well, let's configure again. Now, we'll go to interface. We'll go to config terminal, interface, fast Ethernet 0/2, and switch port mode. This is access mode. So access and then switch port access. VLAN, you need to access VLAN again, 15, right?
Yes.
Yeah.
That's it, exit here. Then again, interface, fast Ethernet 0/3, okay? You can use simply interface, you know, if you want all the, I will tell you later on, 0/3 to, you know, if you want, like, for example, it's not necessary 1 by 1, you will go to 1 by 1 interfaces. You can simply say interface fast Ethernet 0/3 to 0 to, if there are 50, 0 to 50, put them in same VLAN. But right now, this is just the basic configuration. You want to know everything. So that's why I'm just going through it. So interface fast Ethernet 0/3, switch port mode access first of all, then switch port access VLAN 15. Khalas, that's it. Exit from here. Now we have interface fast Ethernet 0/4, but I want it to be in another VLAN. So first of all, always switch port mode access switch port